This is a live example of using parametric memory, a memory substrate designed to do two things. One is relevance in your workflow. The second is a knowledge structure that can be used to feed your agentic workflows with security or policy, or really any domain of knowledge that you want to expose your agentic workflows to. In this case, we've started a new chat, and the problem with new chats is basically that it needs to build the context for what you're working on. Now, this is a continuation of work that I'm doing on a parametric memory substrate, i.e. digital brain for AI. And what I'm going to do now is actually live, and I'm just going to try it, see how it goes. What I want to do is using memory only via MCP, give me the history of parametric memory substrate. Now, the idea here is every time I start a new chat, it will preload and prefetch all of the information about a given subject. In this case, I'm asking it about the memory substrate, which is a project that's in this folder here, Markov-Merkle memory, and I'm not going to give it any more context other than that. It's a very simple start of a session, and as you can imagine, there should be a lot of context missing. So the idea here is when you switch between one session and another, you end up having to reload your context so that the project's up to speed. Now, if you don't, that's a lot of grepping, that's a lot of tokens, and that's a lot of cost for it to understand where we are and what we're doing. You'll notice here we're using an MCP integration, and it's using memory search. So it's listing some atoms, doing a memory search, and then at the moment now it's searching code. What it should do is load the local context with information about the parametric memory substrate project. How does it work? What are the milestones? What have we done to get here today? It's going to go away and it's going to basically use the MCP server to query the substrate. The substrate itself has the ability to use Markov chains to predict the next atom. And we're using Markov weights to reinforce particular atoms to hot feed back into the session context so that I don't personally have to give it that context. So you can imagine every session now wakes up on a fresh session with a bootstrap based on the text in the input string here. And basically what it's doing is it's going and pulling from memory how we got to where we are today. So back in March 2026, we built out the engine. We deployed the first droplet with the server, production migration for jump hashing. Over the course of a 10 sprint weekend, we created most of the things that make this thing work. We created a commercial platform as a way to exercise the memory substrate. So you can imagine that building memory is one thing, but realistically you have to have a project that allows you to explore how to use it, where it's useful, what are the algorithms and the decisions required to make it useful to the average coder, to the average agentic workflow designer. And what we did was go through a series of different steps to make sure that this thing was basically ready for consumer grade use. Now, what's interesting here is that it's actually pulling this memory from the substrate itself. So it's documenting the work that I did whilst I'm doing it. It's documenting facts about the process that we used. It has learnt my way of developing and how I want to structure projects and how I want to manage GitHub and databases, how we manage our infrastructure. All of these things have been saved into this memory substrate so that when I want to go and do something, the skill that has been created will actually reference the memory substrate. The memory substrate will return certain information about how to do that procedure. So not only do you get the power of the skill, but you also get the information and the knowledge from the memory substrate. And what you can see here basically is a very high level milestone report. What actually happened day to day during my view through this. Now, we recently have just completed this benchmark era where we achieved an 83% official sealed and publishable benchmark. That's actually quite an interesting subject because we have added the ability to verify the substrate itself and the tests and questions and answers for the long memory evaluation. We started looking at the V2 version and we killed that because we didn't want to overfit the memory substrate to a specific domain or goal. The idea here is that you can use it for whatever you like. We choose to use it for 3 different purposes. The first one is that the operations uses a memory substrate to run the business. The second one is that we use a research substrate to track progress, to capture information about the project and run books, playbooks, branding, all sorts of onboarding, everything that is needed from a developer point of view. And then the third one is a knowledge structure. So the idea here is that you can create a substrate, feed it whatever sort of domain of knowledge that you're interested in, and then use it as a reservoir or a fast lookup. So an L2 cache, if you like, to then feed back into the context memory of the LLM or the AI. And what this does is 2 things. It allows you to, first of all, create a coding assistant memory and feed back into the cache of the next session. So no more handing over, between sessions and having to create a file so that the new session knows what's going on. The memory does it for you. The second thing that's really important is that this is a compounding memory substrate. So over time, the value that you spend on tokens, the amount of time that you spend in a session, inherently that was lost when you change sessions, and you would only get the benefit of that handover document to continue the context into the new session. What this does is it compounds it over time so that session on session, it updates the knowledge structure in a way that takes all of the learnings from all of the sessions that you're doing. So you don't have to reset each time. The AI can, based again on the original query, take keywords and then look back into the history of the substrate and then pull out all sorts of detailed information. This is a very powerful thing to think about. If you were dealing with CVEs, you could compound them all over the period of, a couple of months, and the more you add into it, the more powerful it is. So you could imagine stocks and bonds, you could imagine coding, you could imagine, any scientific knowledge domain you want. And instead of having to go re-query the internet or do, web search or rewrite out your plan a dozen times or remind your AI a dozen times. It accumulates the stored wisdom and knowledge across sessions so that it gets better and better over time. And what we've got here is basically a universal one-to-one L2 cache for an AI. And you can choose to use it to reload your session. You could choose it to learn absolutely everything about a subject. I have experiments where I've been tracking GPSs for vessels, different ferries and fishing vessels and stuff from all over the planet. This information you can query in plain language. You can ask it a human level question and it will immediately return back to you all of the information around that subject. And interestingly, the ability for it to detect that if you're interested in the Bering Sea fishery, it can detect which are the crab boats and which are the fishing boats, and intimate details about the knowledge that you never thought that you would ever ask a question. It is buried inside the knowledge substrate, and it allows you to query more questions after the fact than you thought you would need before you ingest it. This comes up really interesting when you start looking at things like running a small SaaS business, right? Or running a infrastructure on DigitalOcean. What is it that you would ingest up front in a database that then you'd be able to join and query out later becomes less important. If you structure the data as knowledge, both temporally but also semantically, and in some cases in sequence, you can actually extract more information out of the data based on the structure of the substrate and the atoms that you create than you knew before you created them. This leads to interesting examples where I can ask my substrate, what needs a human today? And all of the data, all of the information in a temporal, semantic, and sequential state is encoded in the atom structure and the memory substrate. And this opens me up to be able to say almost any human level question, and it can produce an answer that gives you insight directly into your operations. Now, this isn't just limited to running infrastructure and code. It could be used across many knowledge domains. So my question to you is, what would you use a memory substrate for other than coding?